Hey everybody, today we're going to be talking about 3.3. We are going to be interpreting graphs. During today's lesson. So, I hope you are ready. I hope you're set to go, because I am. So, let's go. There are no warm-ups today, because notes are a little bit long, excuse me. So, please be prepared to write a little bit today. Okay, so what we are going to be doing, you don't have to write this down. You're going to be given this table and a few problems. And you're also going to be given a situation. In these situations, it's going to relate to a table. And I'm going to talk about this in just a second, but this is the table that you're going to get. Your time, okay, is in hours. Okay, so all three of these cars are given into miles per hour. So this is 50 mph. 50 mph and this is the time. The time up here is going to be let's say 1 p.m., 1:05 p.m., 1:10 p.m., so on and so forth. Okay, so you're going to be looking at this and seeing what is happening based on a situation. All right? So this very first one, you can keep this table up so you don't have to keep rewriting it. It's the same table each time, but a new situation. So write the table down. You only have to do that once. Then write the situation. Okay, so I want you to see or write this down, and then we're going to talk about this. All right, so it says, Mr. Lee is traveling on the highway, and he pulls over to make a call on his cell phone. Then he gets back onto the highway. Okay, so in this situation, thinking about if this was an actual scenario, what would be happening to his speed? So if you look at Mr. Lee's going on a highway, yada yada yada, he pulls over to talk on his cell phone. Once he's done talking on his cell phone, jumps back onto the highway. What would make sense? So in order for you to stop, you have to slow down first, and then if you're talking on the cell phone and you're not moving, think about the speed at that point, and then once you're back on the highway, think about that speed. So what makes sense? Which car makes sense? Car 1, car 2, car 3 for Mr. Lee here. It would be car 3. Car 3 makes the most sense, because when you think about it, car 1, if you look at car 1, we're slowly slowing down from 50 to 50 to 30 to 30 to 0 to 0. Okay, to 0, all right? Car 2, we're keeping kind of at the exact same space, maybe slowing down a little bit, but we're not stopping. Car 3, if you look at that, he starts to slow down right after 1 o'clock, okay? After making his phone call, which he stops right here, the phone call lasts from 1:10 to 1:15, and right by 1:20, he's back on the highway going 55 miles per hour. Okay, so if you look at this, car 3 makes the most sense here. All right, next situation. Okay, you do not have to write this one down, but again, I want you to think in your head. It says Mrs. Healy's driving on the freeway between 1 and 1:20 and encounters no traffic. If you encounter no traffic, I want you to think, what car makes the most sense? We know it has to relate to one of these cars, but which one makes the most sense? Tell the person next to you. Okay, now that you told them the car, tell them why that makes sense. All right, hopefully you said car 2, and the reason why, no traffic. You might be going up and down a little bit depending upon cars in front of you, but as you are in traffic, you're slowing down, you're speeding up constantly. Okay, so you're always moving back and forth, but you're staying around the same speed each time, and Mrs. Healy's car maintains a speed between 50 and 55 miles per hour. Fantastic. All right, so you should have this grid all written down already. It should be set to go. All you need to write down is this situation, the situation. Talking about Mr. Johns this time, all right? So it says at 1 o'clock, Mr. Johns estimates that he will arrive at his destination in approximately 20 minutes. What do you think, which car makes the most sense? All right, hopefully you came up with car 1, car uno, because Car 1 makes the most sense because as you do this, as you're doing car 1, notice his speed is staying at 50 miles per hour. Okay, goes down to 30 miles per hour for about 5 minutes, 10 minutes. As you look at that, maybe he just went into town. He's out of town. Once he hits town, it's 30 miles per hour. Okay, in town. Then it says, though, that Mr. Johns will arrive in 20 minutes from 1 to 1:20. At 1:20, he's parked. He's at 0 miles per hour. He's stopped. So he's at his appointment or whatever he's supposed to be doing. He's probably running to do math problems and math homework at home. I understand it, Mr. Johns. I do it all the time. Maybe not between 1 and 1:20 because I have another class, but after work, yeah, gotta get home. But at a certain time, I'm stopped, I'm parked, I'm doing math. Who does that? Next. Okay, so I want you to write these 3 graphs down. Again, it is very important that you look at these 3 graphs. Please write these down because you're going to have to write down situations, but all used to the same graph. So very similar to what we did before. Okay, I want you to look at these problems. So write the graphs down, show the exact same thing. This says runner's speed here on the left on your y-axis, time on your x-axis. So pause now, write the situations and the graphs. Don't forget about your graphs. All right, here we go. Jamie's running a race. He begins his race, and as soon he feels some pain in his muscles. Okay, pain in his muscles, and slowly he's unable to complete the race. I want you to think about that. What makes sense? If you look at these graphs, we can tell on this graph, on graph 1, a person speeds up and then stays at one speed for one time. Next one, slowly goes down and then sharp drops slowly and gets to a stopping point. Looks like for graph 3, the person's speed is going down, then hits something going up faster, then slower, then faster. Okay? What makes the most sense for Jamie? What do you think? Graph 1, graph 2, or graph 3? Graph 2 makes the most sense because Jamie is unable to complete the race. So the speed, well, when he stops, he can't do anything. He stops, again, we're at 0. Our speed should be 0. In our time, we're not able to finish the race, so he's done running and there's still time left on the clock. Okay, so the time is 0. Again, we're going to be doing different situations with these 3 graphs. So we're going to go to the next situation. Okay. Now we're on to Anne. Anne decides to alternate between running and walking during the race. So again, write this down. You should already have the graphs, but write that down and tell me which one makes the most sense for this. All right? Now that you've told me, why? Tell me why. Well, the answer is graph number 3. Graph 3. Why does graph 3 make sense? Well, because if you think about this, she's going at a good speed, starts to slow down, but she hasn't completely stopped. She's just walking. Once she hits the lowest walking point, she speeds up to start running again. Okay? She hits her breaking point, and again, she has to slow down to start walking. So slowing down to start walking. Oh my gosh, she's walking too long. She got her breath back. She needs to run to finish the race. Okay, looking again, we have runner's speed. As we go up, we're increasing speed. Down, we're decreasing speed. So graph 3 makes the most sense for Miss Anne here. For Miss Anne, graph 3. Okie dokie, artichoke. Next. All right, now Melissa builds up her speed during the race, during the beginning of the race, and she maintains her running speed for the remainder of the race. So how does this make sense? Which graph tells you this? And I want you to explain why. Maybe you know this right off the bat because we're only dealing with 3 situations and 3 speeds, so maybe you can just infer what you know here or deduce what graph it's going to be, but explain why. Don't forget to explain why. So pause and explain. All right, so when you look at this, graph 1 makes the most sense. Why does it make the most sense? Well, if you look at graph 1, Melissa is building up her case here. She's building up, she's running faster, but then she maintains, once she gets to that one spot, she starts running a little faster, gets to that one spot, then maintains the same speed for the rest of the race. That line going straight across didn't mean she get any faster or slower. She just stayed at that same speed. Remember, again, on that left side, we have runner's speed. Stayed at the same pace for the rest of the race. Great job, Melissa. Nice work. Way to run. Good work. Okay. That's all I have for you today. A short lesson, just had a little bit of longer notes. So you are done. You will get your homework tomorrow. I hope you enjoyed this lesson. Now, just go be like Melissa. Go run outside. Burn off some energy. Go have fun. And then when you come back, do some math problems. Have a good night. Bye.